well, praise the Lord who's given us another day on his earth to do physics. And you know, one of my favorite scriptures is in John 17:4 when Jesus says, I have brought you glory on earth by completing the work you gave me to do. And while the Lord could say that at the end of his life, and a lot of us might not be able to, we can at least do our work one day at a time, including our physics homework today. A pulley 14 centimeters in diameter is free to rotate about a horizontal axle. A 270 gram and a 510 gram mass are hung at either end of a massless string over the pulley. What torque will keep the pulley from rotating? And we're going to assume that the string doesn't slip.
God's
Help. You can do physics. Boss, as you are created.
You are created in God's image.
To be fruitful and multiply.
Fill the earth and subdue.
Okay, so to interpret the problem, first thing we want to do is we want to draw a picture. This is a pulley. That's the radius of the pulley. We're going to define a positive sense of torque. You know, if we had already defined a coordinate system some other way, then we'd use the right-hand rule and the rules of vectors to figure out which direction the torque is in. But when there's only one sense of rotation, we just need a positive and a negative. So we're going to make clockwise positive. We're going to note that the radius of the pulley is 7 centimeters, and we're going to go ahead and convert that to meters. And we're going to go ahead and draw the two hanging masses. And we're going to call the heavier one M1. And we're going to go ahead and convert it to kilograms in the process. And draw M2 over here. We're going to note that the force here is equal to M2G, and that's the force of gravity on mass 2, and the force of gravity on mass 1 is M1G. Now we're going to have to take some care when we convert those to torques, because one's going to produce a positive torque and one's going to produce a negative torque, but that's a pretty good start on interpreting. The principle of physics that we're going to use to work the problem is equilibrium. And this is the idea in a discipline of physics called statics, that if there's no acceleration, either linear or rotational acceleration, in a system, it's in equilibrium. And once you determine that the system's in equilibrium, then the sum of all the torques is equal to 0, and the sum of all the forces is equal to 0. And that's a convenient principle to use moving forward in this case.
God has crowned you
with
glory and honor.
Honor to rule over his creation. Okay, so to develop our bullet point plan, this principle of equilibrium leads us pretty quickly to the idea that the net torque is going to be equal to 0. That's our equilibrium principle. That's useful in this situation. So we're going to express the net torque in terms of the stuff that we're given. And, you know, from a practical point of view, we're going to think about that torque tau 1, tau 2, and tau 3. And let's define these. The torque 1 is the torque due to mass 1. The torque 2 is the torque due to mass 2. And now the torque 3 is going to be the unknown that we're solving for. That's the torque that we need in addition to torque 1 and torque 2, so that the net torque is 0. So once we do that, then we solve for the third torque.
Science is a gift from God
to help us master nature.
But sin added thorns and thistles,
requiring the sweat of your brow to succeed. Alright, so we do have this idea that the torque is equal to the moment arm crossed with the force vector, and From a practical point of view, this sort of is a one-dimensional problem. There's only one sense of rotation, and every torque's either positive or negative. There's also the simplifying aspect that each force is applied perpendicular to the moment arm, and the moment arm in each case is simply the radius of the pulley. So with those simplifying factors, the magnitude of each torque is simply equal to the magnitude of the moment arm times the magnitude of the force times the sine of the angle. But since all the angles here are 90 degrees, this sine term is simply 1. So simplifying factors, torque 1. And torque 1, if you recall, is positive torque, right? That's the heavier mass hanging on the right side of that pulley, and it's going to tend to impart a clockwise rotation. So that one's simply going to be R1, F1, sine of 90 degrees is 1. So go ahead and plug in some numbers here. 0.07 meters. F1 is equal to the mass, which is 0.51 kilograms. And then towards the acceleration of gravity, which is 9.8 meters per second squared. Now, you could go ahead and punch the numbers into your calculator, and that gives 0.350 for the number. But let's take some care, and let's think about the units and take some care doing the math on the units as well. So we have meters, and a kilogram times meters per second squared, that's just the unit of force in the MKS system, and 1 kilogram per 1 kilogram times meters per second squared is a Newton. And it's convenient to summarize the units in this case as meters times newtons or Newton times meters. Some physics classes will make a case that you should always call it meter newtons when you're talking about torque, and then Newton meters in other contexts. But units commute. So I don't make a big deal about that. So we call it meter newtons or Newton meters. Anyway, tau 2, the torque 2 to mass 2, is going to be negative because that's the mass hanging on the left side of the pulley. And from our perspective, it's going to tend to impart a counterclockwise torque, which we define as the negative direction as far as torques go. Alright, so negative R2, F2, and then the sine 90 degrees, which simply turns out to be 1, 0.07 meters times 0.270 kilograms times the 9.8 meters per second squared. And so do the math on the numbers. It's negative 0.185, and then our reasoning for the units, meters per second squared, our reasoning on the units is similar. Kilogram meter per second squared is newtons, and the meter out here, so 0.185 negative meter newtons. Alright, let's go ahead, just come over here to finish the evaluate stage of the process. Now the net torque,
Learning physics
often requires prayer
as we submit
to Jesus Christ
as risen.
as risen King of Kings and Lord of Lords, is torque 1 plus torque 2 plus torque 3, and that all has to be equal to 0, going back to our equilibrium condition. So torque 3 is equal to negative torque 1 plus torque 2. And so we've solved for those over here. So this is negative 350 Newton meters. 0.350 Newton meters. And then minus 0.185 Newton meters. A little bit of math there. It's negative 0.165 Newton meters, which is the additional torque that needs to be added. Okay, now when we think about how do we assess this answer, it's kind of convenient to go back to our picture here.
We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes success
Success in our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor. All right, so we've got two hanging masses, and these are the forces. And when we think about the units, does it make sense that the units of our answer are in Newton meters? Yes, it does, because the torque itself, by definition, has units of distance, the moment arm, times units of force in newtons. So it makes sense that our units of our answer are in Newton meters. Does it make sense that the torque is negative? It does in the way that we define it here, right? The heavier mass is hanging off the right side and giving it a positive torque. The lighter mass is going to reduce that, but it's not going to overcome it. So the third torque that we need to add, it does make sense that it needs to be negative. And if you look at the magnitudes of the individual torques, then it makes sense that the magnitude of the third torque is sort of between the larger torque and the smaller torque for the reasons that we've discussed.
Written in the Word, in the good Word, is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good Word, is a message from our God. Gonna tell you all about